Hi, it's Doug. Have you ever thought about this? We use the word energy in some totally different situations. Like, on the one hand, we talk about energy and our body. Think about when you're running around. People might tell you, you seem hyper, you have lots of energy. Or think about when you're sick, for example. When you're really sick, it's the worst feeling. That feeling where you just don't even feel like moving. You just lie there, barely wanting to do anything. We say, "Oh, I feel like I have no energy." So that's energy in our body on the one hand, but we also talk about energy when we think about things that aren't even alive, like computers and smartphones and cars. We all say these things need energy in order to work. Could it really be the same thing? After all, we get our energy from what? Food? But cars, they get their energy from gasoline. Or if they're electric cars, then from batteries. Could it really be that the stuff that's in food, whatever this thing is that we call energy, is really the same thing as the stuff in gasoline and batteries? What do you think?
Do you think the energy used by people and the energy used by cars is the same thing?
We've all heard that we get energy from eating food. To make that a little more real, consider this guy. This is former Olympic swimmer Michael Phelps. He's won more gold medals than anyone in history. Athletes who compete in sporting events know that they need a lot of energy. Well, what do you think Michael here eats for breakfast? He eats 3 fried egg sandwiches with cheese, lettuce, tomato, fried onions, and mayonnaise. That's a pretty big meal. But that's not it. He also eats French toast and pancakes and grits. Oh, plus an omelet, all for breakfast. That's a ton of food. But all of that food has energy stored inside, which Michael Phelps's body uses in order to move his body and swim as fast as he does. Still, is this energy that's stored in our food the same energy stored in gasoline, the energy used to power cars? I mean, people can't run on gasoline. But think about what happens when a car runs out of gasoline. Sometimes people have to get out of the car and push it to make it move. That would be a car running on people. And since people run on food, technically then, this is a car powered by the energy stored in food. Still, that seems a stretch. Could a car be powered directly by food? It is possible. A car can't digest food the way our stomach does. But believe it or not, this truck has a special engine that runs on French fries. The drivers collect the oil that the French fries cooked in and pour it into the gas tank. The truck's exhaust even smells like French fries. Now, here's a bus that runs on beans, soybeans specifically. They grind up the beans until a liquid oil comes out, and that gets turned into fuel. Someone has even created a race car that runs on chocolate. So, just like people use the stored energy in food to move, cars can use the energy in food to move too. And it's not just cars either. For example, some toy rockets are actually powered by sugar. You've probably heard that sugar is one of the foods that has a lot of energy stored in it. Now, keep in mind, that doesn't mean it's healthy for you. But check this out. This is a video of someone using sugar as energy for a rocket. First, he melts the sugar in a pot until it's golden brown. Then, he pours the melted sugar into the rocket, just like this. When he lights the fuse, the rocket blasts off into the sky. Wow, that gives you a real sense of just how much energy is stored in sugar. All of this is just to show you. Energy isn't just some cute expression that we use, it's a real thing. Energy may not be something you can see or hold, it's not an object, but it is real. inside a battery, inside of food, inside of gasoline, there is something stored up, which, when it gets released, makes things start moving. That thing or ability to make something start moving, that's what energy is. Batteries, food, and gasoline are just a few of the things that contain energy stored inside of them. But there are even other things that can store energy. We've talked about real cars, but consider something like this, a wind-up toy car. Where does a wind-up toy car get its energy from?
Where does this get its energy from? A wind-up toy car. Where does it get its energy from?
Wind-up toys are a classic toy of childhood. I'm sure you've played with one before. You know you have to wind it up to make it move, but have you ever thought about what's going on inside a wind-up toy? Well, have a look at this one. As you open up this wind-up toy, you immediately see there's no battery inside of there. So, where does it get its energy from? How does it move? This thing, right here. This piece of metal here, that's all coiled up, is a type of spring. When you twist the knob, you're winding the spring tighter and tighter. You see that? A spring is something that can store energy, just like a battery or just like gasoline. The coiled spring inside of a wind-up toy car might not be something you've seen before. The more classic-looking spring, like this one, is one you might be more used to seeing. But it's the same kind of spring, like if you've ever used a pogo stick. As you press down on the spring, it stores energy, then releases it again, causing you to bounce back up. Where else can you find energy being stored and released? That's something we'll keep coming back to throughout this unit. You're going to get to explore and play around with energy. You'll even get to use what you learn about energy to design fun and useful things. Starting today. Let's consider one other way that energy can be stored. In these rubber bands. If energy is the ability to make something start moving, then rubber bands are definitely something that can store energy. One of my favorite things to do, and with this you have to be careful, is to use a slingshot. It's basically a huge rubber band that you pull back and then try to launch something. Like in this case, launching apples at targets. You can see when you pull way back on the rubber band, the apple can fly all the way across the field. Now, I hope it goes without saying, but never use a slingshot indoors. You can even use rubber bands to make rubber band-powered racing cars, where the more you wind them up, the farther and faster they go. There are so many creative ways of using rubber bands to make something move, like even this toy airplane. Now, why is it that the more you stretch a rubber band, the faster you seem to make an object go? Why do you think that is?
The more you stretch a rubber band, the faster an object goes. Why?
In today's activity, you're going to build a new amusement park ride for the company Acme Amusements. The ride is called the Twist-O-Matic, and it works by twisting rubber bands, which store energy. When the rubber bands are released, they use all that stored energy to spin the riders around and around and around. Now, the real full-sized amusement park ride hasn't been built yet, so today you'll be testing a model, a smaller version of the Twist-O-Matic. Your goal is to figure out how to make the most exciting ride. We'll show you how to get started, step by step. Get your supplies. Each person will make their own Twist-O-Matic. If you're working alone, you'll want to make two.
So right now you need the Twist-O-Matic template. Looks like this. You need a pair of scissors and 2 different colored crayons.
Fold your Twist-O-Matic in half along the thick dark gray line like this. Now, when you do this, be sure to press down with your fingernail to make a good crease. Then fold it in half again on the thin line, and make a good crease there too. Okay, it'll look like this when you're done.
Okay, so fold it. Fold it in half once, and then you fold it in half again. So he's folding it in half, and then on that next black line, he's folding it in half again. Kind of like our Foursquare.
It's helpful to color one side of the Twist-O-Matic to make it easier to see as the ride spins. You don't want to spend too long on this step, so we'll just color the riders' outfits. Use one different solid color on each rider so that you can tell them apart from one another. You can use any two colors you want. This should only take you about a minute, so I'll set a timer in case that's helpful. Okay, it's been a minute. Go to the next step. Alright, now what you're going to do is find the back of the Twist-O-Matic. Then cut along the two dotted lines until you get to those stop signs you see there. See how this creates this flap of paper? You'll fold that flap up like this and match up the pictures. You'll make the fold a nice crease with your fingernail. Then flip the whole thing over like this. Fold the flap back down, match up that picture again, and make another crease on both folds using your fingernail. So it should look like this when you're done.
Okay, so the first thing he did was cut along the lines through both pieces. Yeah, cut on one, cut on the other dotted line. Then after you cut on that same side, fold up, lining up that little arch there. Okay, make a crease. Then you flip it over and fold the other part over to make a crease. Okay, now you have your Twist-O-Matic. Okay.
All right, go ahead and get these supplies. You'll use them to set up two Twist-O-Matic models. Also, you should decide which of you will be Clipper and which of you will be Ruler.
So you're both of these people. You're going to be the clipper person and the ruler person. So you need a ruler or something. I mean, you could use a pencil instead of a ruler if you wanted to. You're also going to need the two rubber bands that are in your bag. You will need the binder clip. You only have one that's in your bag, and then you need something heavy to hold on to it. If you don't have a ruler, that's fine. You can use anything that you have in your house.
The Twist-O-Matic uses rubber bands to store energy. So we need to turn the rubber bands into strips. Clipper, cut the thin rubber band like this. Ruler, cut the thick rubber band like this.
Okay, so you're going to take both of the rubber bands. One of them should already be cut in half. The other one you will need to cut. So all you're going to do is make one little snip, and that cuts it in half. And then you need to make a cut in the other one. Okay, so you have 2 rubber bands, both that are cut.
You'll be comparing 2 Twist-O-Matics, one that uses a thin rubber band and one that uses a thick rubber band. To make sure that we have a fair test, we need both rubber bands to be the exact same length. So, clipper, line up the tops of the rubber bands like this. Hold them down near the bottom. Ruler, if they're different lengths, cut the longer one so that they're both the same.
Okay, so your next task is to make sure that both of the rubber bands are the same length. You have one thin one and one thick one. They both need to be the same length. So if you have to cut them, go ahead and cut them now.
Now let's add the rubber bands to your Twist-O-Matics. Have the riders facing you, like this. Then, ruler, hold one end of a rubber band on the short middle line like this. Then, clipper, close the binder clip over the rubber band to hold it in place. Okay, repeat these steps for the other Twist-O-Matic and rubber band.
Now, you only have one Twist-O-Matic, so we're going to start with the thin rubber band first. So go ahead and clip just the thin rubber band. Once we test the thin rubber band, then we will do the thick one after, okay? We're just trying to save on supplies. So you'll do this one, mark the thin one, and then put it in your folder so that it's in a safe place, because tomorrow we're going to be testing the Twist-O-Matic. So just make sure that you are all set up and ready to go for tomorrow.